Hey guys, last review. We've done Unit 7 so recently I'm not going back through gases. There are gas questions on the final, but we're up to Unit 6, which, like the notes from the packet say, this was not a favorite for a lot of you with equations and stoichiometry. But the good news is I'm going for the big ideas only on the final, and it's going to be what I review here. So there's none of the complex stoichiometry problems, no crazy writing equations. We're going to balance, we're going to classify, going to do simple stoichiometry, only mole to mole, which a lot of you guys can do in your head, and a percent yield calculation, which is just like figuring out a grade. The first big idea from this packet was the law of conservation of mass, the why we balance equations. In ordinary chemical reactions, the ones we can do in a lab, the ones we do in our little beakers, not the crazy ones with the hydrogen bomb or the center of the stars or the throwing atoms at hundreds of miles an hour at each other. None of those. That's not what I'm talking about. I'm talking about like water, like hydrogen plus oxygen. Look, I made water. The kind of things we can do in class. We do not create or destroy matter. We do not create or destroy mass. So, to show that I don't create or destroy mass, when I write an equation, I want the same number of both things, of all things, on both sides. So if you look at the example I gave you in your packet, it is combustion of methane. It's the lighting my farts on fire equation that we talked about before. Again, don't look on YouTube. YouTube knows. So for this equation, what we're looking at is I've given you masses of reactants and of products. The masses of the reactants add up to the same as the masses of the products. They're equal. Why? Because I have the same number of carbons, hydrogens, and oxygens on both sides of the equation. That's why balancing equations is a thing. So, let's add some coefficients to these. We're going to go through this. At the end, there's a practice for you to do, and I'll post the answers. And if you have any questions, check with me. You can work on those as you go. But today, we're going to balance. Next time is classifying, and the time after that is the basic math. So, let's see what we've got here. We've got synthesis of ammonia. We've looked at this equation so many times. Right now, as I look at this, I see two nitrogens, so I only have one on that side. If I put a 2 here, then 2 times 3 means I have 6 hydrogens, so 3. You might be wondering, how can I do this on a multiple choice test? How you can do this on a multiple choice test is underneath here there are 4 choices, and one of them, your coefficients say 1, 3, 2. 1 nitrogen, because if there's no number out in front, it's 1. 3 hydrogens, 2 ammonias. I'd look over that for a mini quiz too. So let's see what we've got for this next one. All right. Well, that doesn't look too bad. Looks like I have 2 hydrogens and 1 hydrogen, 2 chlorines and 1 chlorine. So 2 HCl. All right. I told you I wasn't going to give you any crazy ones. This one's kind of weird. I hope you remember that if I have H2O on this side, I could write it as H2O. And I think I just went back through and added that in your packet too. I think there was a missing thing there. So if I look at this and go, I could do this. There's 4 hydrogens. Remember, this means 2 oxygens and 2 hydrogens. But also remember, if I have H2O, I can rewrite it as H and OH if I want. Now, check it out. I have 2OH and 2H, meaning all I need there is 2H2O. Now I've got a magnesium on each side, because remember that 2 goes to the parentheses, but not to the magnesium. 4 hydrogens, 2 there, okay. 2 oxygens, good. Dog food. Alpa. Now, actually, aluminum phosphate. The reason I put this one on here was because I wanted you to remember that if I have PO4 on both sides, an ion, a polyatomic ion on both sides, I can balance it just like it's an element. So since I have 2 PO4s on that side, I don't have to break it down into P and O and all of that stuff. 2 phosphates, 2 phosphates, so 2 aluminums, 3 calciums, and 3 calciums. Done. equations are balanced. Next time I'm going to let you look at some balanced ones, and if you want to look ahead in your packet, it's classification as synthesis, decomposition, single and double replacement, and combustion. Coming right up. See you next time.